Hello everyone, welcome to the second tutorial video of QGIS. In this video, we will be dealing with some of the basic terminologies which may come across while we are using QGIS. Let's begin with the most commonly used terminologies of QGIS, that are points, lines and polygon. Point is data comprising sets of individual x and y coordinates but are not joined together. They are used to represent hospitals, schools, etc. Line is data which has two ends but don't meet, possibly with intermediate points. They are used to represent rivers, roads, railways, etc. And polygon is data containing one or more closed lines, forming shapes which can be filled. They are used to represent administrative boundaries, land masses, etc. Second is attribute table. An attribute refers to a piece of data relating to a feature, for example, the name of a settlement or population of a region. And an attribute table is a table showing the attribute values for all features in a selected layer. We can see the example of attribute table in QGIS as shown here. And each row of the table represents a features, which may be with or without geometry, and each column contains a particular piece of information about the feature. The feature in attribute table can be easily searched, selected, edited, or moved. Third, vectors and features. Vectors are data represented as a set of coordinates producing lines, points, or polygons. When anything that we can observe on the landscape, including roads, rivers, trees, houses, schools, etc., are represented in a GIS application, it is known as a feature. Simply, feature refers to an individual object in your data. Vector data are used to show the real-world features within the GIS environment. Here we can see the example of vector point features, line features, and polygon features. Fourth, raster and imagery. Raster is a map data which is represented as an image with pixel values ranging from 0 to 255. Raster data are matrices of discrete cells representing features on, above, or below the surface of Earth. Every cell in the raster grid is of same size and the cells are always rectangular in QGIS. Typical raster datasets include remote sensing data such as aerial photography or satellite imagery, and modal data such as elevation metrics. Unlike vector data, raster data typically do not have an associated database record for each cell. They are geocoded by pixel resolution and the XY coordinate of the corner pixel of the raster layer. This allows QGIS to position the data correctly in the map canvas. Here we can see the example of raster point features, line features, and polygon features. Another commonly used terminology in QGIS includes Coordinate Reference System (CRS). A CRS defines the translation between a location on the round Earth and that same location on a flattened, two-dimensional coordinate system. With the help of CRS, every place on the Earth can be specified by a set of three numbers called coordinates. The coordinate reference system is made up of several key components. First, coordinate system, the XY grid upon which your data is overlaid and how you define where a point is located in space. Second, horizontal and vertical units, the units used to define the grid along the X, Y, and Z axis. Third, datum, a model version of the shape of the Earth which defines the origin used to place the coordinate system in space. And fourth, projection information, the mathematical equation used to flatten objects that are on a round surface, example Earth, so that we can view them on a flat surface, example our computer screens. In general, the CRS can be divided into geographic coordinate reference systems and projected coordinate reference systems. The decision as to which map projection and coordinate reference system to use depends on the regional extent of the area you want to work in, on the analysis you want to do, and also on the availability of data. Geographic Coordinate Reference System. The Geographic Coordinate Reference System uses degrees of latitude and longitude, and sometimes also a height value to describe a location on the Earth's surface. It includes an angular unit of a measure, a prime meridian, and a datum. Its use is very common, and the widely used Geographic Coordinate Reference System is World Geodetic System WGS 84. As mentioned earlier, this coordinate system locates latitude and longitude location using angles. Therefore, the spacing of line of latitude moving north and south is not uniform. This is the reason why another projected coordinate system has been developed. For most geographic coordinate systems, the prime meridian is the longitude that passes through Greenwich, England, as shown in this figure. And other countries use longitude lines that pass through Bern, Bogota, and Paris as prime meridians. Projected Coordinate Reference System. A projected coordinate reference system is a flat two-dimensional surface commonly defined by two axes. At right angle to each other, they form a so-called XY plane, as shown in this figure. And unlike geographic coordinate reference system, a projected coordinate reference system has constant lengths, angles, and areas across the two dimensions. A projected coordinate system is always based on a geographic coordinate reference system, that is based on a sphere or a spheroid. It is a coordinate system that is localized to minimize visual distortion in a particular region. Example, Robinson, UTM, state plane, etc. 6. Geoprocessing tools. According to Environmental Systems Research Institute, geoprocessing is a framework and set of tools for processing geographic and related data. The comprehensive suite of geoprocessing tools can be used to perform spatial analysis or to manage GIS data in an automated way. The available geoprocessing tools for analyzing data on QGIS are listed here. Lastly, base map. The term base map refers to the collection of GIS data and/or orthorectify imagery that provides a background of geographical context for the content you want to display in a map. Also, it adds aesthetic appeal to a map, and the base map in QGIS includes a variety of choices including topography, imagery, and streets. Here we can see some example of base map that we can use in QGIS. That's all for this video, and in our next video we will be discussing about the anatomy of QGIS in desktop view. Thank you. You can get connected with us through our official website, Gmail, Facebook and Instagram page. Thank you.